Hello, friends. I'm sending this recording to you for answering some of the questions students have asked me pertaining to nonlinear optimization technique, a program elective. Um, they had some fear about this subject, and that fear was because of non-linear prefix to the optimization techniques. Earlier name of this course was optimization technique simply, and that time this course used to be very popular. Maximum students used to opt for this course in 7th or 8th semester. Earlier, this course used to be in 8th semester. Later on, it was shifted to 7th semester, right? So, after prefixing the nonlinear word to the optimization technique, the popularity of this course slashed down, and that prefixing was done because of the recommendations given by some of the members in board of studies. The contents were same. Okay, so this should make you understand what is there in the name. Okay, name, because of the name only, whole the change in the popularity of the elective occurred. Okay, now because of the name, non-linear prefix to the optimization technique, the popularity has gone down. Okay, this elective that way is very important for the students who will be going for their masters, or who will be going for masters of business administration, or any other course they will be doing. If they want to pursue their studies ahead, this is the course they will be having in their curriculum wherever you will be um, trying to get admission to. Secondly, optimization is the need of today of almost every sector, every industry. And mostly the problems formulated are not linear problem. Okay, you will find that most of them in their objective function, or their objective function is non-linear, or some of the constraints are non-linear, that makes whole the problem non-linear. But be sure that the techniques used for solving the non-linear optimization problem are simpler as compared to the techniques you have studied for solving linear optimization problem. They are mostly search algorithms, right? So I'll be briefing you about various contents of non-linear optimization techniques. Will be very first unit in non-linear optimization technique is the Lagrangian multiplier technique. The names are hard, but the techniques are very simple. Okay, Kuhn-Tucker condition and Lagrangian multiplier, Lagrangian function for optimizing nonlinear function. Okay, you will understand this technique just in one lecture. Okay, one lecture is enough for covering one unit of your syllabus of nonlinear optimization techniques. What is done in this Lagrangian function, the constraints are absorbed in the objective function by assigning some penalty coefficient to the constraint. Okay, if the constraint is violated, the penalty will get automatically added to the objective function, right? And if those are satisfied by some of the solution, then the penalty will not be added. Okay, that is how you will be getting Lagrangian function, and once you get the Lagrangian function by applying some Kuhn-Tucker conditions, which are very simple conditions. You will be getting some equations. Solving those equations will get you the optimal solution. This is the stuff which can be covered just in one lecture. Okay. Normally, there, mm, to what extent you have learned will be tested by one question in your examination, right? So the very first unit you will be learning is finding the optimal solution to nonlinear programming problem by Lagrangian function and by the use of Kuhn-Tucker condition. Okay, very simple, right? Everyone, irrespective of what their score was in mathematics or operations research one or two, they can score well in this technique. But unfortunately, this technique is good for solving it manually. For finding the optimal solution by computer, this technique is not much better or good, right? For that, you have the techniques, and the reason why this technique is not good for computer, why this technique is not computer friendly, the reason is differentiation is not a comfortable operation for computers. It requires you to have used library for differentiation, or you need to use digital differentiation techniques. Okay, so we will not be going into that. We will be having another techniques for finding the optimal solution for nonlinear optimization problems, and that technique will be starting from optimization of single variable nonlinear problem without constraint. Okay, like some expression is given to you with single variable, for example, mm, minimize x to the power 5 minus pi x cube minus 20x plus 15 or so. Okay, only one variable is there. There is no constraint, and you have to find the value of x, which will be giving you the minimum value of z. Okay, but now you don't have to use differentiation. Okay, so you will be using some search technique. There are few simple, very simple search techniques. Okay, one technique will be dividing the span within which the minimum for this expression lies into two parts and eliminating one part. Then whatever half part remains, you will be again dividing that part into two parts and eliminating half part likewise. Okay, this is called as dichotomous search method, right? Likewise, there will be another such techniques wherein we will not be dividing the segment or the span within which minimum lies into two equal parts. We will be dividing them into unequal parts, and for dividing that in unequal parts, we will be taking the support of Fibonacci series or golden section, or we may be fitting a given polynomial by means of quadratic expression or cubic expression or the combination of these two. All this appears to be little hard to listen, but when you actually use this technique, you will find that it is very, very easy, right? Because it is a search process, and all throughout you will be needing some or other mean for eliminating um, some of the section of the span to reduce the span within which the minimum will be lying. Okay, all these techniques are very simple. You can manually, it will not be taking much of the time to solve the single variable nonlinear optimization problem without constraint, right? So this is called as NLP1. Then the knowledge of NLP1 will be extended to solve the problems, nonlinear programming problems, wherein there will be more than one variable. Okay, what we will be doing, we'll be converting this multivariable problem to a single variable problem, multivariable non-linear programming problem to a single variable non-linear programming problem. And you know the techniques, you have learned the techniques for solving in single variable non-linear optimization programming problem in NLP1, and those then will be used for getting the optimal solution for multivariable non-linear optimization problem. Okay, right? There are few methods, against very simple methods for solving this kind of problem, multivariable, non-linear, unconstrained optimization problem. Okay, names may give you a feeling that it is difficult, but it is not at all difficult. Those are very simple techniques. Okay, those are very computer friendly techniques, but we are going to learn them to be able to solve the problems manually. And if we get time, we'll be doing some demonstrations to use these tools in MATLAB. Okay, simply a function will be entered and the name of the technique, the function relating to the name of the technique will be called, and you will get the optimal solution. Okay, through exam point of view, all these are very simple. Then, depending upon the relationship between arithmetic mean and geometric mean, that arithmetic mean is always greater than or equal to geometric mean. Okay, this we have studied in dynamic programming. Using this principle, a geometric programming technique, very attractive technique, very popular technique, has been developed. And by using that technique in one shot without any iteration, you are going to get the optimal solution. Okay. At this occasion, I cannot explain you how you will be getting the optimal solution in one shot. But so far, whatever you have learned in operation research was an iterative process. Geometric programming is one technique which is non-iterative. It will be giving you the optimal solution in one shot. Okay, so these are the four units. The first one was Lagrangian function related, very simple. Then second one is called as NLP1, third one NLP2, and fourth one geometric programming. All this is going to get covered in 1 plus 5 plus 5 plus 3. So far the four units are getting covered in for 13, 14 lectures. Okay. Then the two units are very important, and more their importance is mostly because of the era of artificial intelligence, wherein optimization techniques will have to be more done by using the algorithms called a genetic algorithm. You must have learned, you must have listened the name of genetic algorithms in simulated annealing, ants colony optimization, particles or intelligence. Okay, and many of you might have run away from by listening to these names. Okay, but it will be impressive um, if you know these techniques, and these are very simple techniques. Okay, these are called as meta heuristics. Okay, little beyond heuristics. Okay, these are also some of these algorithms are bio-inspired algorithms. Okay, like in genetic algorithm, this has been inspired from the Darwin's theory that every generation is better than previous one, and another statement of the Darwin's theory is um, Darwin's theory of evolution is survival of fittest. That means there is a competitive element included in the generation. For surviving, you have to be fit, you have to be better than others, right? And that will make the next generation mm, better than previous one. Okay, this is implemented for making the population of previous solution, population of current solution better than the population of previous solution. And that is how in every generation of the solution you are improving the solution. Okay, you are improving the population of solution. Okay, that is genetic algorithm. Okay, with these few lines and little of my explanation, when I'll be explaining you genetic algorithm, you will find that you unnecessarily had been fearing of genetic algorithm. It is very simple. Okay, ants colony, you see that the ants in search of their food, they initially wander randomly. And after you see that there is line of ants, you have to be sure that they have searched the prey, and the line of ants which you are seeing is the shortest path towards their food. Okay, and they go on spreading, spraying some element that is called a pheromone, and the which gets evaporated if more time pass over it. Earlier, ant will be secreting pheromone on which another ant will be moving. And if it takes longer time for the ant to reach to the destination, this pheromone will get evaporated sufficiently, right? And another ants won't be uh, the probability of selecting that path by another following ant will be very less. Okay, with these clues, you will be understanding how the ants find the shortest path, right? Then the birds, flock of birds, you will be seeing they fly in the air with a beautiful formation. Okay, by and keeping the nearness either to their destination or to the prey. Okay, we will be mathematizing, or we will be implementing, will be computerizing this behavior to get the optimal solution. Simulated annealing, okay, you know the annealing process wherein the heated metal is left for systematic cooling, slow cooling, okay, whereby the crystalline structure is formed within the metal. Okay, these are some stories which I am explaining you, but the stories are utilized for getting the optimal solution. You can have your own story, and if there is some optimization clue or minimization or maximization clue in that story, you can implement that story to a method. You can form a method out of that story. Okay, these three, four algorithms will help you to get your own algorithms, right? So this is all about the syllabus. it, it can get completed in something like 25 lectures, but I'll be extending it for uh, helping you to get most out of it. Okay, that is you. Trying I'll be making you to use some softwares, or I'll be making you to develop some software, but that's not mandatory, because I know some of the students are reluctant to enter into software development, program development, but there is opportunity for the students who are interested in developing the programs. So voluntarily, some of you can enter into developing the program. Some of you can find some application to apply these techniques which you have learned. These techniques will be required quite often in the real field. Okay, the syllabus, the contents are mathematical, mathematicals with very less encounter with the mathematics itself, right? Mathematics is not much involved, mathematics, and the understanding point of view, the course is easy. Scoring point of view, the course is attractive, right? You don't need to be worried about mm, the non-linear world in the um, course name, non-linear optimization technique, right? So I think that's all about this course, right? Okay. We'll stop here. Just a minute. So that's all about this course. You may know about other electives before you choose the elective. Okay. The choice of elective should be based upon how that elective is going to be helpful to you. Okay. Mm. And don't look at the elective through the perspective of ease or difficulty, right? That way, this is easy, right? But even if you have the liking of another elective, and if it is difficult to, but because you overweigh your liking than the difficulty, okay, right? So all the best. Hmm? Thank you so much. If you have any question, you can call me, hmm, mm, pertaining to the contents of this and any other thing as well. Thank you so much.